All right, our last section of chapter 4 is 4.5 on isosceles and equilateral triangles. So let's go over what an isosceles triangle is to start. So a triangle that has two congruent sides and two congruent base angles. So if we're looking at this isosceles triangle, these right here are the legs of your triangle, and they should be congruent as they are marked right here. And then your base is then the side at the bottom where you have base angles that are congruent. Okay? So your base angles are touching your base, and those are congruent when your legs are congruent, which is what we'll go over right here. So if two sides of a triangle are congruent, then the angles opposite of those sides are congruent. This is your isosceles triangle theorem, because if you have these legs marked as congruent, then you have an isosceles triangle where you should mark the base angles congruent. So we've got these arrows because this angle right here is opposite of this side, and this angle right here is opposite of this side. Okay? So what we could conclude here, knowing that our legs are congruent, is that angle A is congruent to angle B. Now, the converse of that would be if two angles of a triangle are congruent, so you've got these two angles congruent down here, then the sides opposite of those angles are congruent. So go opposite of this angle and mark this as congruent to opposite of this angle would be this leg right here. So now we can conclude that AB, this side right here, was congruent to side AC right here. Okay, so isosceles triangles can be shown as isosceles triangles if you have the base angles congruent or the legs congruent, but then you know all of that information once you know that it's an isosceles triangle. Okay, so let's use the isosceles triangle theorems here. So is AB congruent to CB? Let's look. So if I'm looking at sides here, then if I'm using isosceles triangle, I want to see if the base angles that go with it are congruent. So AB is this side, and BC is this side here. So the base angles would be these right here, and they are marked as congruent. So then I can say that my legs are congruent. So yes, because the base angles are congruent. Okay? Now, let's see. We can do, is angle A congruent to angle DEA? So angle A is right here, and angle DEA means that angle is right here. If I want to show that those angles are congruent, then I would need the legs to be congruent of this little triangle here. Notice I'm using this little one here now because I'm looking at these two base angles. My legs are congruent, so I can mark my base angles congruent. So this one is also yes because the legs were congruent. Okay, so because we had the legs in this one, we can mark those angles, and then above, because we had the angles congruent, the base angles, we can mark the legs. All right, let's go to the next page. We'll actually look right here. We've got theorem 4.5, ran onto the wrong page, but it says if a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. So let's flip that page and fill that out. So what that means is if AC is congruent to BC, so I've got an isosceles triangle, and ACD is congruent to BCD, ACD is congruent to BCD. So CD was an angle bisector here. Then I know that CD is perpendicular to AB. So CD would be perpendicular to AB, so I can put in these right angles. and the AD was congruent to BD. So CD was an angle bisector up here and a perpendicular bisector to the base. And that only works with isosceles triangles. So let's do an example with that. What would the value of x be here? So let's use our information. We do have an isosceles triangle, and we do have this top angle bisected. The vertex angle was bisected up here because those things are marked. So then the information that I would know is I have right angles here. There we go. And I would know that these two are congruent. So that should help me to find x, because if I know this angle here is x, I know this one is x. And then why don't we look at this as a separate triangle. Oops. There we go. If I look at this triangle, I can pull this out and let's redraw it, okay? So I know this is 90 now. I was given that this one was 54, and I now know this one is x. Okay, so I actually know 2 out of 3 of my angles, and I know that angles should add up to 180 degrees. So I can do 180 minus 54 minus 90 to get the value of x. So go ahead and solve that and see what you get for x. Alright, you should have gotten 36 degrees for the value of x. And double check, that was all that it was asking us to find, so we are done with the problem. Alright, so that's our isosceles triangles. Now we've got equilateral triangles. This says, if a triangle is equilateral, which this means that all my sides are congruent, okay? So these are all marked as being the same length, okay? So if it's equilateral, then the triangle is equiangular. So that means all of my angles would be congruent as well. So in other words, if all the sides are equal, all the angles will be equal. Equilateral triangles, everything is equal. So now, what would the measure of all of the angles of equilateral triangles be? Well, we know that triangles add up to 180 degrees. And I have 3 angles that are all going to be the same measure. So I can divide this evenly into 3 angles, since they all have to be the same, and I know that each one will actually be 60 degrees. So whenever you have an equilateral triangle, every angle is 60 degrees, okay? The sides can be anything. They can all be 4 centimeters. They can all be 10 feet. But the angles will always all be 60 degrees. Okay, so we're going to use that in our problem here. Let's do one example. So given the triangle ABC below is an equilateral triangle, let's mark on our picture, as you should always do with geometry. Draw on that picture. So I marked all my sides congruent because it said it was equilateral. I can also mark all my angles congruent if it's equilateral. Find the value of x. Okay, so I know that all those angles are congruent, but it doesn't quite tell me what I would maybe set 4x plus 8 equal to. But you know that every angle of an equilateral triangle is equal to 60 degrees, so we can set this equal to 60. Because we know this should be 60, this should be 60, and this should be 60. So we'll go ahead and solve and subtract 8 and get 4x equals 52. Divide by 4 so that x equals 13. All right, and it just said to find the value of x, so we are done. So that's your basics on isosceles and equilateral triangles. We'll do some more practice in class.